All right, so this is our wrap-up video. Today we learned about section 2.5, substitution. I told you that we were going to go over all this stuff, mostly just introducing substitution, telling you the types that you'll use, and then going through those examples. And again, I'm going to say, please send requests for exam 1 review and integrals. But so we talked about how we use substitutions, and we kind of said we want to make a change of variables that makes ODEs easier to solve. We knew how to do that for regular integration, and for ODEs we're going to solve about the same set of steps. I guess one thing that we didn't say right here that maybe I should have said explicitly is remember to back substitute. For y, same way you do after an integral. And then we gave the list of common substitutions. So there's the proportional substitution that y is u times x, or sometimes you can say x is v times y, but they're kind of the same approach. But you use it if you see things like x to the p and y to the p appearing in your differential equation, if it's in differential form, like you saw for exact equations. Or x over y if you're already looking at dy dx on like the left-hand side of your equation. There's also going to be u is y to the 1 minus n. That's for Bernoulli's equation type problems. And then the linear combination u for when you can write a function of that linear combination on the right-hand side of your differential equation. So we did an example of that proportional substitution in differential form. And we didn't solve that integral because I didn't want to. We remembered that we have to solve for y at the end of it though. And then we did an example where we were looking at kind of the derivative form, but used that same substitution. And this one we did solve, and then at the end we did our back substitution like we're supposed to. And then we had an initial value problem, so we plugged that in, and we remembered that you have to do the initial value problem part at the end of your substitution after you've put it back in terms of your regular variables, or else you have to remember to be very careful. Then we did our little word problem application using that Bernoulli's equation approach. We got a solution, but when we talked about the solution, we realized it's just the logistic equation, which can also be solved as a separable equation. And then lastly, we did that linear combination problem. I cheated and did not show you the integration live because it was kind of slow, but we got a final solution for u, and it was pretty good. So in conclusion, kind of the big takeaways here are there are 3 types of substitution you should be able to identify. Doing like y equals ux, doing u is y to the 1 minus n, doing u is a linear combination of x's and y's and constants. You need to remember to replace dy or dy dx with du or du dx when making your substitution, just like you do with u substitution in calculus. You have to remember to actually solve for y for your solution. And it's usually easier to wait until that point to plug in initial conditions. So that is use y equal to a bunch of stuff, not u equal to a bunch of stuff. And then any other important tips here? I'm not thinking of any. Oh, actually, that thing with the separable logistic equation is sort of something that we saw with exact equations too, but there are lots of ways to solve ODEs. So use the easiest one. And your participation problem for this week is going to set you up for your web work, but we're going to identify the correct substitution for y prime equal to 4xy plus 18x squared plus 2y squared over x squared, and transform to a separable equation. Oh, actually, that's kind of well. So I'm just saying, here's a differential equation, y prime being dy dx. Usually I try to, wow, that was a big eraser. Try to write everything out for you instead of using the prime notation, but that's what web work had. So just use substitution on this equation. Don't actually solve the separable equation, just get it set up for yourself, because I don't want you to spend that long on it. Just demonstrate that you understand the substitution part. And I will see you in class.